All right, today's lesson is all about distance. Okay, distance can be described as the length on a graph, and we'll talk about that coming up. Let's go ahead and find the length of the segment between the following 2 points. So point A is at 4, 0. That's for here. This is point A. And point B is at 4, 5. Okay, point B. We want to find the length of the segment AB. Let's consider that segment. Okay, well, we're talking about length of a segment. Okay, put our two letters down. Okay, and if this were any other number line, we would just count the distance between them. So let's go ahead and do that. 1, 2, 3, 4. It looks like it's 5 units away. That was really easy because this segment fell directly on one of our lines on the graph. Okay, but that's not always going to be the case. Let's consider the following example. Okay, let's go ahead and find the distance between the points 1, 1. Okay, we'll call that point C. Okay, so point C here, and we'll call this point D, -2, 3. That's point D there. Okay, this time, the distance between these 2 points looks a little bit different because we're no longer on one of our lines on the graph. Okay, we're going to have to find the distance between those 2 points a little differently. If we think back to 7th and 8th grade, we wanted to find the length of a side of a triangle. Okay, we would have to use the Pythagorean theorem. Let's review our Pythagorean theorem from way back then. On a right triangle, two sides that form the right angle, this guy down here, are called the legs. So on our triangle on the bottom, we've got leg A and leg B. The side opposite the right angle out here is the hypotenuse. Our Pythagorean theorem says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. What? What in the world are they talking about? Well, let's consider the following triangle. Triangle ABC, where we've got legs A and B and hypotenuse C. When we take the hypotenuse and square it, it equals the sum of the squared legs. In other words, A squared plus B squared equals C squared. Let's go ahead and find the length of the missing side. We've got the following triangle with legs A and B equal to 12 and 5. Doesn't matter which one we label which, as long as they are the two legs. So we'll just call this one leg A, and leg B equals 5. We need to use the Pythagorean theorem, A squared plus B squared equals C squared, to find the missing side. Well, C is unknown, so we need to leave that in terms of C. Now, A was 12, so 12 squared plus 5 squared has to equal C squared. Okay, well, 12 squared is 144 plus 5 squared is 25 equals C squared. Well, that sum here is 140, 50, 69 equals C squared. Okay, and if you don't know, okay, take out your calculator. But in order to solve for our missing side, okay, we take the square root of both sides. Okay, that's the inverse operation of squared. So C is going to be 13. So our missing side is 13. We're going to use the same idea to find the distance between our 2 points. Okay, this is from that previous example. So let's make a right triangle. There's one leg, and here's our other leg. Okay. Well, we know that from here to this bottom vertice would be 2, and from there to there is 3, and we don't know the side opposite this right angle yet, so we'll call that C. Well, I know that 2 squared plus 3 squared equals C squared. 2 squared is 4 plus 13 squared, excuse me, not 13, 3 squared is 9 equals C squared. Well, 4 plus 9 is 13 equals C squared. And to write our answer, we square root both sides. C is the square root of 13. Okay, 13 is prime, so I know I can't simplify this radical any further, so I found that missing side. Next example says to find the distance between the following 2 points. 3, negative 2, and negative 1, 4. Again, we're going to use the same idea of the Pythagorean theorem where it comes to a triangle to find this missing length. And we're going to call that C for now. Okay, it's still that hypotenuse of the triangle. And we've got the following 2 legs. Let's go ahead and count the length of these legs. 1, 2, 3, 4, 5. Looks like this one's 6. And the bottom one is 4. 1, 2, 3. Yep, 4. Okay, so the Pythagorean theorem says that a squared plus b squared equals c squared. So I take 6 squared plus 4 squared equals the square of the hypotenuse. 6 squared is 36. 4 squared is 16 equals c squared. I'll add these up, I get 52 equals c squared. And my answer would be C equals the square root of 52. Now we can call that answer good enough. If I wanted you to simplify that square root, we want to break this up into a pair of square roots where one of them is the largest perfect square in there. Okay, so if I think I know 4 and 13, when I multiply those together, I get 52, where 4 is the largest perfect square factor of 52. Okay, so C equals root 4 times root 13. Well, the square root of 4 is 2. Okay, so C equals 2 times square root of 13. Like I said, this answer right here, okay, we'll call that good enough for now. You could type that into your calculator and get a decimal, but we're going to, at some point, we're going to try to strive to get to these more exact answers. So this would be the exact answer down here on the bottom. Example 3. Find the distance between the points -1, 4 and 5, 7 right here. Okay. Let's go ahead and count the bottom. 1, 2, 3, 4, 5, 6. And this right side, this other leg would be 3. So I know that 6 squared plus 3 squared equals c squared, the hypotenuse squared. Okay. 36 plus 9 equals c squared. So I've got 45 equals c squared. Taking the square root of both sides, I get c equals the square root of 45. And I know that I could break this up into the square root of 9 times the square root of 5. I chose that because 9 is the largest perfect square factor of 45 there. Okay, so when I simplify this, I get 3 times, not root 3, times the square root of 5. Okay. Now if I were to type this into my calculator, I'm going to do that really quick. Okay. The square root of 45, so square root 45, I get 6.71. Okay. If you do the same thing on your calculator on the bottom here, you get a decimal approximation, 3 times the square root of 5, you'll get the exact same thing. Okay. This would just be called the, like we said in the last slide, the exact answer. Okay, for right now, we'll probably just accept this and that'd be okay. But just know if I ask for the exact answer, we're going to want to try and find those perfect square factors. Okay, instead of always having to count the legs of our triangle, we can sum this process up by using the distance formula. And the distance formula says that d, so the distance, equals the square root of the difference in our x term, so the difference in the x's squared plus the difference in y's squared. Now, how in the heck is that the same thing? Well, x2 minus x1, that's essentially just counting the distance between our two x's. If we're looking on our coordinate plane, and that's my x-axis, okay, let's just say, for example, the first part is at 2, 0, and the next part is at 5, 0, okay? Well, x2, this guy, minus x1, that guy, is 3. So the distance between that is 3. So it's the same thing as just counting the distance between there, but now we have a physical formula to find the distance. Okay, we'll do one of these together, and I'll leave the last two for you guys to try on your own. Okay, let's do number 4 together here. So find the distance between the 2 points. We're going to label our points. We'll label point A, x1 and y1, and point B, x2 and y2. Remember, the distance formula equals the square root of x2 minus x1 squared plus the difference in our y's squared. Okay. All we're gonna do is just plug our numbers in and simplify. So d equals square root of x2, which is 3, minus x1 from our point, which is 0, squared, plus y2, which is 4, minus y1, which is 0, squared. And again, all of this is underneath our radical symbol. Okay, I'm going to go up here, finish this guy out. Well, square root of, okay, in this first piece, 3 minus nothing is 3. Square it, I get 9, plus 4 minus 0 is 4. Squared, I get, let's see, 4 squared is 16. Okay. Well, 9 plus 16, I get square root of 25, and that's one of our perfect squares. So the distance between point A and point B is 5. I want you guys to do the other two examples.